In this section, we talk about factoring and solving polynomials using techniques that we've already learned, mainly with quadratics. We're just going to kind of tweak them a little bit and show you how to use them when we talk about polynomials of higher degrees, like the third and the fourth power. The first technique that we talk about is the easiest way to solve a quadratic, and that's when you're given a difference of two squares. You're given a difference of two squares, like a squared minus b squared. You should know that automatically factors into a plus b, a minus b, or vice versa. It doesn't matter which one you put first. I'm going to show you the proof of a difference of two cubes, a cubed minus b cubed. And just like a difference of two squares, this has a particular form that it factors into. And it's always a minus b times the quantity of a squared plus ab plus b squared. And I'm going to go through this proof real quick just to show you where this comes from, where this formula comes from. So here I have two cubes, even though it doesn't look like it. This real big cube here, the orange, the a by a, and this side over here would actually be a also. This whole side would be a. So it's a by a cubed, that's a cubed. And then this little bitty piece that's missing, this little piece right here, this is b. So I've got b, and then this side would be b, and this side would be b, so it's a b by b cubed. Therefore, I've got a cubed, and I'm missing a little spot, and that spot is b cubed. So I'm actually, this is a geometric representation of a cubed minus b cubed. I've got a cubed, and I've taken away that volume from b cubed, so I'm left with the volume of a cubed minus b cubed. So to find this geometrically, I'm just going to figure out the volume of each piece, the orange piece, the green piece, and the blue piece, and add those all together, and that should give me my total volume. So I'm segmenting this and adding it together to give my total volume. So let's see, let's start with the orange piece. So what is the volume of this orange piece? Well, volume is length times width times height. So remember, this a right here, this is the entire thing, right? That's the whole side is a. So I got my length down here and my width, that's a times a. And I can figure out how tall this orange piece is right here. Well, if the whole side is a, and I know this height is b, then the length of this orange piece will be the whole side a minus b. So this is the volume of the orange piece. And it's a minus sign there. So when I multiply this, I get a squared times a minus b, which is a cubed minus a squared b. That's the orange piece. Just finding the volume. So now I'm going to look at the volume of the blue piece. The volume of the blue piece, so I've got this side right here, this side up and down, that's b. And then this side right here is also b. So I've got b and b. Now I gotta figure out how far is this right here. Well, again, if this whole side is a, so from here, let's use a different color. So if from here, and I draw a dotted line all the way out to, oh gosh, that's not supposed to happen. All the way out to here, right? That's kind of how it extends for. That whole side is a. And I'm missing this piece. So I'm missing these last few dots, and that distance is b. So actually, I've got b, write this in blue. I've actually got b times a minus b, which leaves me with b squared times a minus b, or a, well, let's write the b cubed first. B cubed minus ab squared. And then lastly is the green piece. So the green piece, I'm looking at this height right here, which is b. I'm looking at this width right here, which is a. And I'm looking at the distance from here to here, which again is going to be a minus b. So this time I've got a times b times a minus b. So that's ab times a minus b. And I'm actually going to focus on, if you look, each one of these things has something in common. Each one of these sections has something in common. They all have an a minus b in common. So I'm actually going to use the highlighted form when I add these together because I want to keep that common factor. So when I add all these together, when I'm adding them all up, I look at orange plus blue plus green. That's going to give me my total volume. So I do a squared times a minus b plus b squared times a minus b plus ab times a minus b. And because each one of these has a common factor, I can factor that out. So I'm going to do a minus b, the quantity, times what's left. Well, to get this whole piece here, I have to multiply by a squared. To get this piece, I multiply by b squared. Then this piece, I multiply by ab. And just doing a little bit of rearranging, you'll see that I want to put this in order. So I do a squared plus ab plus b squared, which is exactly what I told you the formula was. If you scroll back up, there it is. There's the exact formula we just talked about, and that's where it comes from. So it's kind of a nice, neat geometric proof to show you where the difference of cubes comes from. And that's what this is called, difference of cubes. So just like you can use a formula with difference of squares, you can use a formula with difference of cubes. So we're going to solve a couple examples like that. So the first one, I've got x cubed minus 8. That is a difference of two cubes. X cubed is obviously a cube, and 8 is 2 times 2 times 2. 8 is 2 cubed. So I'm going to use this formula right here. So first I'm going to identify what my a and my b are. Okay, so if I treat this as a cubed minus b cubed, then this means that a equals x in this case, and b equals 2. So I'm just taking these values and plugging them straight into my formula. So a minus b becomes x minus 2. A squared becomes x squared. A times b, so that's just 2x. And b squared, which is 2 squared, which is 4. And there it is. That is the factored version of the difference of two cubes. Next example, I look and 2x cubed is not a perfect cube, and 54 is not a perfect cube. But the first rule of factoring for anything, polynomials, quadratics, whatever, tells me to always look for a common factor. So I see a common factor here. That common factor is 2. So I'm going to factor a 2 out, and I'm left with x cubed minus 2 times 27. It gives me 54. Now I have a difference of cubes. X cubed is obviously a cube, and 27 is a cube. 27 is 3 cubed. So I'm going to do the same thing here. I'm going to identify what my a is and what my b is. And I'm just plugging those into the formula. So this becomes x minus 3, x squared minus 3x plus 3 squared, which is 9. And there's your factored version. Difference of two cubes. Just had to memorize the formula. Just like a difference of two squares, but a little more complicated. Okay, the next couple examples, we're going to solve polynomials that look like they're in quadratic form. So this is called quadratic techniques. And these aren't quadratics, if you look at them. There's x to the fourth, x squared, and there's 10, a constant. So these actually are not quadratics. They're quartics. They're to the fourth power. But we can solve them like we would a quadratic. Because if I replace these variables, so if I made this x squared plus 7x plus 10, you should be able to solve that. That is a normal quadratic. You would solve that by finding two numbers that multiply to give you 10 and add to give you 7. So we're going to treat this like a quadratic, and we're going to use a little technique called use substitution. So when you recognize a problem that has something to the fourth and then squared, so you're looking at the leading power, and then the next term is half the leading power. So in this case, 4 and 2. This would also work if it were something like x to the sixth plus 7x to the third plus 10. Again, leading power and then the next one is half the leading power. Or you could say x to the 10th plus 7x to the 5th plus 10. That would also work because, again, leading power, and then the next one is half the leading power. So when this is the case, your u that we're going to use, what you're going to substitute is always your middle term. That's always going to become your u, your u. So let me show you how to do this u substitution. So we're going to make x squared a u, and it's going to look weird, but that's okay. Just go with it here. So we're going to say u equals x squared. So every place there's an x squared, we're going to put a u. So this is going to become, I'm going to change this x to the 4th into x squared squared plus 7x squared plus 10. Now I'm going to change x squared to u, so I'm left with u squared plus 7u plus 10. Now this should look familiar. This should look like a normal quadratic that you've been solving for the last couple years. This is just u squared plus 7u plus 10. Just variable quadratic form. You find two numbers and multiply to give you 10 and add to give you 7. That's fairly quick. We're going to make it u plus 5 and u plus 2. That's two numbers that multiply to give me 10, 5 and 2, and add to give me 7. And now I just plug back in my x squared. So now that I've factored it, I can just plug back in x squared. So x squared plus 5 and x squared plus 2. Now, do you need to use u substitution? No, you don't have to. If you can immediately see that this is going to factor into x squared plus 5, x squared plus 2, then no, you don't have to use u substitution. I like to use u substitution so you can see that it will factor just like a quadratic. So this looks just, this step right here looks just like a quadratic. That is something that everybody should be able to solve, and you should be there. Next problem, try it on your own. Doing the exact same thing, we're going to use u substitution. I will help you identify your u. Your u is going to be your middle term, which in this case is x squared. So at this point, pause the video, work through this problem, and see what answer you get. Okay, so the first thing you should do is rewrite the problem with x squared. So I'm going to do 4 times x squared, quantity squared, because this is technically x to the 4th, minus 5x squared minus 9. My next step is going to be to do u substitution. So I do 4 u squared. Actually, I don't even need the parentheses there. So 4u squared minus 5u minus 9. So here we have to factor this. And there's a couple quick ways to factor this. We can use the bottoms up method. We can use the diamond method, or whatever method is comfortable for you. But I want to find two numbers that multiply to give me 36 and add to give me 5. So two numbers that multiply to give me 36 and add to give me 5. So you should see that this factors into 4u minus 9 and u plus 1. So 4u minus 9 and then u plus 1. And then our next step is to sub the x squared back in. So we get 4x squared minus 9 and x squared plus 1. But we're not quite done, and this is kind of tricky. We are simplifying or factoring completely. And if you look, 4x squared minus 9 is actually a difference of 2 squares. So we have to take this one step further and factor this difference of 2 squares. So this just becomes 2x minus 3, 2x plus 3, and then our x squared plus 1 is left on the edge. So remember when it says factor completely, this is not done. You have to keep going. Just because we're out of quadratics don't mean we need to forget how to factor a difference of 2 squares. The last method we're going to talk about is factoring by grouping. And this is exactly what it says. You're going to do this when you have 4 terms. And you can't always factor by grouping. It doesn't always work, but it's a technique that you can try. Because because once we learn how to do other polynomial techniques, this will be like, I want to draw grouping. So grouping exactly what it says. We're going to use parentheses to group terms, and we're going to see if they have the common factor. So usually what you can do is kind of scan the problem real quick and see what two terms would have common factors. If I group these first two terms, they have a common factor. If I group these last two terms, do they have a common factor? That's what you want to. That's what you want to look for. So yes, if I group these first two terms, this x cubed minus 2x squared and the 4x minus 8, they have factors in common. So x cubed minus 2x squared, the factor they have in common is an x squared. So I can factor that out. X squared times x minus 2 plus, and then this common factor is 4. So plus 4 times x minus 2. Now, when you factor by grouping, you have to make sure that these two are the same. If they're not the same, it's not going to work. So usually you can figure out by the first step that factoring by grouping is not going to work. And the reason these have to be the same is now this becomes your common factor. Both of these terms, so this is one term here, this is one term, and this is another term. Remember, terms or monomials are separated by a plus or minus sign. So here we have two things multiplied together and two things multiplied together separated by a plus sign. So I can look at both of these terms and see it has a common factor of x minus 2. So I'm actually going to pull that x minus 2 out. So x minus 2 times, and I say x minus 2 times what gives me this first quantity, and that is x squared. And then x minus 2 times what gives me the second quantity, and that is 4. So that's it. Factoring by grouping. If you are familiar with factoring by grouping when you factor quadratics, then this should be pretty easy. And that is it for factoring and solving. We didn't really solve any polynomials, we just factored them. But if I set all these equal to 0, I could go through and solve all of them for x. In the next video, we'll talk about other methods and other techniques on how to factor polynomials, specifically polynomials of degree 3 or greater.